like to talk to you about Chapter 1 in Print Reading and Specifications. Every project has a set of contract documents, and the contract documents for a project are comprised of the drawing set as well as a project manual. And in the project manual is where you find the specifications for a project. The method by which that is delivered will impact how comprehensive the drawings would need to be for that. And in the chapter they talk about a process called design, bid, build, and in that the drawings that are part of that set really need to be a complete set of documentation, because the documentation for the project, both the drawings and the project manual, will get sent to those that are bidding on the project, and everybody is bidding on the same set of documents and the same information. And so then they put together their costs for the project, the bids are open, and the team, generally the owner and the architect, will sift through those bids and select the one that they think will be most appropriate and yield the best building for the client. In that case, those drawing sets need to be very comprehensive. In a design build situation, the contractor will generally work with a design team. They'll often set a price for a project up front, and then the documentations will be a little bit more open-ended. The team is kind of working together to bring that project in with the underneath the cost that they had predetermined. That's often one of the ways. This particular chapter really talks more about the prints as far as on the side of the contract documents. Later we'll get into a bit more about the specifications and what each one of them are showing. But it's really an overview of what goes into the drawing set in a project. So in terms of conventional drafting, manual drawings were the original method by which documentation was carried out for a project, and they were done generally by hand, and there were some different methods by which that was done where various people could work on the drawing at one particular time. That was superseded by CAD drawings or computer-aided drafting, and you're using methods that will more efficiently produce a set of drawings. At least that's the theory of it. You can see in the bottom here, there's a sketch, and while manual drafting is still not the norm anymore, I would say that drawing is still utilized, whether it's at the preliminary stages where you're quickly trying to flesh out the ideas for the project, and then those get implemented into the CAD drawings, or whether it's just taking a set of CAD drawings and marking them up so that somebody can make those changes. It's still important to have some skills by which you're able to convey information. So one of the benefits of and rationales for moving into utilizing the CAD is that there is the consistency in the drawings. So you don't necessarily get my drawing style being slightly different from somebody else's drawing style, and everybody needing to work on a set of documentation. There's consistency of having uniform line widths and symbols and how we represent those drawings. It makes it very easy to make revisions and changes, adding, deleting, etc. Layering of information, so you can turn on and off information depending on what you're trying to show for that is easy to do within the CAD system, whereas before it was literal layers of drawing or one vellum over top of another. Being able to view the building and modeling it in different ways, as well as being able to store drawings in electronic mediums and being able to take those to the job site and have that information there, as well as the physical space. Duplication, where you can create the documentation for a project and then duplicate it very quickly, as well as information management for a project. That is slowly transitioning to what is called Building Information Modeling, or BIM. And in this case, you are, rather than creating two-dimensional drawings for a project, you're creating a three-dimensional model of a project, and you're extracting data from that. So it's also thinking of it maybe more as virtual construction, where you're building that model and then extracting data out of that model. So some of the advantages with that are, if you're building it as you go, and you can see over on the right where it's showing the supply and return area for a building, and you have structure that would also be in place, and all the other building functions and components, as well as finished systems, you might be able to identify where there might be problematic areas where things don't have enough space to run, or there was maybe a misunderstanding of what was happening within a room. You also get automatic updating of views, so when something in the model changes, it changes inherently in all of the areas that might be impacted by it. And then being able to, again, extract analytic information about that model versus what you could do in the computer or CAD drawings. So a lot of the drawings, or how we arrive, whether it's using CAD or BIM, there are different types of drawings. And this is more based on when we're doing either manual or doing CAD, or how we're depicting the model. So there are three basic types. There's isometric, perspective, and orthographic drawings. And we get into those in much more detail in other courses within the architecture program. When we're talking about isometric drawings, we're looking at a drawing where the principal axis is about 120 degrees, and those faces are skewed. They're somewhat realistic looking models or views of the object. They're still used for piping diagrams. So in a set of drawings, you might see that as an isometric drawing, so you can see how it is being supplied throughout the building. This is isometric of just a little building, so you can kind of see how you see those three views of the project and that 120 degree angle. If you look at the corner, each one of those, when added up together, gets to that 120 degrees. So we're not going to be doing it other than really looking at the isometrics that are used by some of the other trades within it. Architecturally, we may do a little isometric to maybe describe how some flashing might be done on a roof edge, but generally it's more something you'll see in other trades. Perspective is a pictorial drawing that shows an object really when it's viewed from a certain point. So whether you're standing off to, if you were in front of a building, if you're off to the right or to the left, the perspective will be skewed based on where you're standing. It's the most realistic because it's the most closely related to how we would really see a building when we're looking at it. And there are different types of perspective drawings. There's 1-point, 2-point, and 3-point perspectives. And there's a little bit of a difference in what you show. On the left here, you see this is a 2-point perspective where we have two vanishing points. This is most accurate for where we would see an object rather than either looking at it from a bird's eye or worm's eye view. They are still sometimes used to hand-drawn and kind of sketch through some things to try to quickly work out some details of a building. And then on the far right, you'll see this is a Revit model where you can see that the perspectives are also being created or can be created and viewed as you're building that model. Orthographics are, orthographic drawings are also called multi-view drawings, and these are where the faces of the object are projected onto flat planes. So this is Classically, how we create drawings of buildings, or how it was done, I should say, before BIM, where you're creating basic views of the drawing, front, back, right side, left side, or how we might think of them as elevations. And I'm going to show you kind of this, where the front is the length. It shows the length and the height of it. The right side is showing the depth of the project as well as the height, and that can be projected up to that top view where you have the length and the depth of that. So as you are describing that object, you are able to transfer that information from one view to another view. And you can see how on this, where you have a plan, these elevations correspond to the side of to each side of the building. This would be considered the south elevation. So even though you're standing here and looking north, it is considered the south. This would be the north, the west, and the east. And it's really better to describe a building based on the views of it rather than front, right side, and top. The alphabet of lines, or kind of the way we use line work to describe a building, is really to help with the clarity of the drawing, so that there are some established standards that everybody knows with regard to how we show information on a document. So while this doesn't have a great set of line weights associated with them, it does describe some of the line types that we use. So the dimension lines are what are dimensioning whatever feature it is you're trying to describe. So in this case, at the bottom you have the face of the building and the dimension to the center line of the window. And you see that center line denoted here, and the dimension is here. Now, there's lots of ways in which you can describe dimensions, as you will see later on. There's the extension line that, again, is denoting the point, one point of that dimension and the other point. There's the hidden line, which is showing either information below or above the cutting plane. The object line is where you are cutting through the object. And then you have a leader line, which is showing information about an object that is pointing to. And then sometimes you'll see a break line. Sometimes the drawing will just stop as well. So there's some consistency in what really should be every set of documentation, no matter what or who is producing that drawing set. So with scales within a project, obviously you can't have a drawing set that has the exact or actual scale of the drawing. And so we have to represent the building in a way that will fit on a sheet. I mean, that's important. And what we're representing, or what we're showing, would suggest a corresponding scale for that, depending on the information. So you need it to be large enough so that the drawing information is clear. That's important, so that whoever's looking at that drawing can see what it is you are showing for that. The most common scale for working drawings depends, again, on the what you are showing. So floor plan is going to have a different scale than what you would use for a detail on a building section. Generally, floor plans are 1/8 inch scale or 1/4 inch, which means for every 1/4 inch is equivalent to 1 foot. Sometimes if you have a very large building, you might have to drop that scale down a little bit more, or you might have to do key plans. The elevations should always be at the same scale as whatever you have for the plans, and the same thing for the sections. So, and by sections I mean the building sections. So those always are the same scale within that drawing, or within the drawing set. Doesn't mean you don't have to do larger views of those, but they should at least start out at the same scale. And then again, as you get into other features, those scales will increase. So when we're looking at a set of drawings, generally the drawing should be able to, or should have all of that information. You should never have to scale, meaning measure anything on a set of drawings. If that isn't on the drawing set, then there's documentation that is missing. Again, you shouldn't have to ever use a tool to measure that information. It should be found there if it's been documented properly. So those should be provided as required. So here you can see a couple of different ways in which dimensions can be utilized in a set of drawings. So the terminus of the dimension can be arrowheads, slashes, dots. You are showing where that dimension is stopping and starting, and that should be very clear. If you have multiple dimension, the cumulative dimension needs to meet whatever that overall dimension is. Here you can kind of see a project that has a variety of dimensioning. Typically, it is given in feet and inches. If it's less than 1 foot, it would only be given in inches. Oftentimes, the dimension is actually not breaking up that dimension string, but is right above that dimension string. And then if there's angled portions, you need to also give the degree angle for that. So again, you're needing to locate all parts of that building. The working drawings or contract drawings will show exterior walls, interior partitions, really anything that is necessary to construct that building using the conventional representations for doors, windows, building components, as well as symbols, and then using the typical drawing conventions. So to describe a building, typically you start with a site plan. Plot plans are kind of an older term rather than, I would say, the newer site plan designation. So here you see a site plan over to the right. It is a scaled working drawing. Generally, it will be at an engineering scale because you're showing the entire lot for the building. So it's going to show the size and shape of the building lot. It's going to show the location and shape of the building, the overall size of the building, where it is located off from the lot. It's going to show parking and access to the building, and then there will also be information on elevation. So what the basic site elevation would be, you can kind of see here some of the contours and some landscaping. Often that will be a subsequent drawing in the set. The floor plan is a view of the project where you're looking at part of that drawing or the drawing as a horizontal section cut. Generally, we assume that that section cut is taken at 5 feet above the floor line, and then anything that is cut through is designated on the floor plan. And so you can see some of those basic symbols for doors and windows. Later on, we'll talk a little bit more about how dimensioning works, where you're dimensioning. Again, here is the openings in the first row of dimensions. The second row is larger, whether it's to the structural grid or to larger cumulative dimensions, and then the overall is the furthest one out. So it depends on if you're looking at it from the other way, you're looking at it from the outside in. So it's getting more specific as you work your way in from the dimensions. And then on the inside, components to the building are all shown or dimensioned on the inside of the building. Often corridors are used to show dimension strings. They can get pretty busy, so the more we can utilize standard drawing conventions, the better we will be in terms of being able to see information for the building plan. Elevations, both exterior and interior, are a scaled view looking at a vertical surface. So you can see these are some exterior elevations. They're denoting material types, where the structural grid is located, control joints for material, or where there needs to be separation of materials, and some of the basic elevations are noted off to the side. Interior elevations are going to be at a much larger scale and be showing information that you wouldn't see on a plan drawing. Building sections. So here is a longitudinal building section. It's going through the length of the building. The transverse section is going through the short direction of the building, and it's basically showing you the overall way in which the structure, what's happening in elevation, overall information about the building. It does further describe materials and information. So you'll see this here that is noting a wall section. So this wall section is over here on a different drawing set. The scale's getting bigger. The type of information that is being shown is getting more specific, and that has a call out for, in this case, what's happening at the coping, and even within that coping detail, there's yet another detail to show how the materials are interacting with one another. So it's getting, the scales are getting bigger and larger, so you're going from 1/4 inch to 3/4 to 1.5 inches as you're showing more specific information in that set of drawings. So trying to go through that set of drawings, there are some things that we show or that are common elements that are utilized within it. We're trying to always simplify it because, as you saw on that floor plan, they get pretty intense and pretty busy as you are showing lots of information. So utilizing tags and symbols and indicating information and trying to make those as clear as possible for those who are looking at that set of drawings. But being able to read those is really important to being able to find the information that you need in order to construct the building. So some common, outside of just those sheets, typically there's a cover sheet, and that will have those that are part of the construction process. So it typically will indicate the owner, the architect, the engineers. It will identify what building codes are being followed in that set of documents, whether that's on the cover sheet or on the next information sheet. So it'll talk about which building code, what's happening with zoning, if there are LEED sustainable information, or if it's a sustainable project, that will often be on there. So that's identified in either the cover sheet or the second sheet. The title block is also probably the first place that you want to look when you're going through a set of documentation, because it's going to identify whether it's an architectural, mechanical, plumbing, electrical, civil. That's going to be indicated on the title block as far as which part of the project you're looking at. And then internal to each one of those disciplines, there will be information associated with the architectural drawings, the plumbing, etc. There's a pretty standard set of abbreviations that are used. Typically in our drawing sets, those abbreviations would be noted generally on the second sheet in a project so that everybody's clear what those abbreviations stand for. It again helps to keep the drawing set as clean as possible, and then how to read the symbols that are also used on that. Also in a set of drawings you would have schedules, so things like door schedule, window schedules, room schedules. those sort of like finish schedules will also be part of that documentation, and then a variety of details depending on how complex that project is. The specifications are the companion piece to the drawings. We're going to talk a lot about specifications as we get into the semester. They help to clarify and reinforce any of the information that's on the working drawings, set of drawings for a project, and those two things are used in tandem. So hopefully this, I know it was a pretty brief overview of the Chapter 1 information. If you have any questions, please let me know.